This video is a summary of all the conventions that need to be noted and understood when solving for exponential equations. To start off, let's see what happens to the square roots or the fourth roots or the sixth roots, or in fact any even root of a positive number. Well, the square root of a positive number will always be positive. Likewise for the fourth root or the sixth root or any even root. Let's take a look at the square root or the fourth root or the sixth root or any even root of a negative number. We all know that the square root of a negative number will be undefined. Hence, any even root of a negative number is undefined. Now let's take a look at the cube root or the fifth root or the seventh root or any odd root of a positive number. This should always give us a positive answer. Likewise, any odd root of a negative number will always give us a negative number. Now let's see what happens when we raise a positive number to an even power. Well, this will always give us a positive answer. Think of 4 squared. The answer is 16. What happens when we raise a negative number to an even power? Well, this will also give us a positive answer. Think of -3 squared. This gives us positive 9. And what happens if we raise a positive number to an odd power? This will give us a positive answer. Think of 2 cubed. That gives us positive 8. What happens when we raise a negative number to an odd power? Well, this will give us a negative answer. Think of -2 cubed. -2 times -2 times -2 gives us -8. Now that we are clear about all the basic conventions, we can now approach some examples of solving exponential equations covering all the conventions needed. Let's go through a couple of examples of solving exponential equations where the unknown is in the base. Firstly, let's look at x to the half is equal to 4. Maybe this is better understood as the square root of x is equal to 4. The square root of any positive integer will always give us a positive answer, and the square root of a negative number will be undefined. So, an answer of 4 is most definitely possible. We can now go ahead and solve this equation. X to the half raised to the power of 2 is equal to 4 raised to the power of 2. This leaves us with x is equal to 2 to the 4, which is equal to 16. Let's look at x to the half is equal to -4. This means that the square root of x is equal to a negative number. We know that the square root of a number is not equal to a negative number, but always equal to a positive number. Hence, there is no solution for x. Now let's look at x to the third is equal to 2. This is the same as saying the cube root of x is equal to a positive number 2. This is indeed possible. The cube root of a positive integer will give us a positive answer. So 2 is most definitely valid. We can go ahead and solve this equation by raising both sides to the power of 3. This leaves us with x on the left is equal to 2 to the 3, which is 8. The cube root of 8 is most certainly 2. Now let's take a look at x raised to the power of a third is equal to -2. This means the cube root of x is equal to a negative number. Is this possible? Yes, the cube root of a negative number is equal to a negative number. So we can continue trying to solve this equation. we can raise both sides to the power of 3, and that leaves us with x is equal to negative 8. And the cube root of negative 8 is most definitely equal to negative 2. X squared is equal to 4. Is there a possible solution for x? Yes. X could be a positive integer raised to 2, which could indeed give us a positive answer. X could be a negative integer raised to 2, would still give us a positive answer. So we suspect that there are two solutions for x. We can go ahead and solve. X squared is equal to 4. We could square root both sides. Remember, we just said there are two possible solutions for x. So don't forget that it's equal to plus or minus the square root of 4. This leaves us with x is equal to plus or minus 2. Positive 2 raised to 2 gives us 4. Negative 2 raised to 2 gives us 4. X squared is equal to minus 4. This is impossible. Any number raised to an even power results in a positive answer. Therefore, there is no solution. What about x cubed equals to 8? Is this possible? Yes. A negative number raised to an odd power leaves us with a negative answer, but a positive number raised to an odd power leaves us with a positive answer. So we can go ahead and solve this equation by cube rooting both sides. In this case, x is equal to 2. And x cubed equals to negative 8. We just said a negative integer can be raised to an odd power and leaves us with a negative answer. We can go ahead and solve this equation. By cube rooting both sides, we get x is equal to negative 2. So now let's take a look at x to the power of 4 over 5 is equal to 16. Is this possible? This is the same as saying x raised to the power of 4 and then fifth rooted is equal to a positive answer. Well, a negative integer raised to the power of 4 makes it a positive integer, and the fifth root of a positive integer is equal to a positive answer. Likewise, a positive integer raised to the power of 4 is still positive, and a positive integer fifth rooted is equal to a positive answer. Thus, we suspect two solutions for x. We can go ahead and solve this equation. What we could do is we could raise both sides to the power of 5 over 4. Just remember, we suspected two solutions. Don't forget to say plus or minus. This leaves us with x is equal to plus or minus 2 to the power of 5, which is 32. And x to the 4/5 equals to a negative number, negative 16. Is this possible? X raised to the power of 4 and then fifth rooted is equal to a negative integer. Or once again, any integer raised to an even power gives us a definite positive, and a positive integer, fifth rooted, will give us a positive answer. So therefore, negative 16 is not a possible answer, so there is no solution for x. What about x raised to the power of 3/4 equals to 8? This is the same as saying x raised to the power of 3 and then fourth rooted is equal to a positive answer. If x were a positive integer raised to the power of 3, this would leave us with a positive answer, and the fourth root of a positive answer is most definitely positive. However, if x were a negative integer raised to the power of 3, that would leave us with a negative answer, and the fourth root of a negative answer would be undefined. Thus, we only suspect one solution for x. we can go ahead and solve this equation. We could raise both sides to the power of 4 over 3, and this leaves us with x is equal to 2 to the power of 4, which is 16. And x to the 3/4 equals to a negative number. This means x raised to the power of 3, 4th rooted, equals a negative number. Is this possible? Well, firstly, x raised to an odd number depends on x. If x is positive, raised to an odd power leaves us with a positive number. The 4th root of a positive number is positive. Let's see what happens if x is negative. A negative integer raised to the odd power will give us a negative number. And the 4th root of a negative number is not possible. Therefore, this equation has no solution. I hope this helps. Just remember, when solving an equation, first ask yourself, is this possible? Before wasting your time on actually solving. If ever in doubt, solve, but then check your solutions, put them back into the original equation, and if it doesn't balance, it's not solvable.